Hi everyone, it is Mrs. Palermo. I am obviously not in class today, but I wanted to make a quick little video for you. This unit's been kind of like broken up and spread out because of Thanksgiving for the most part. So I just wanted to go through some of the main topics that will be on Monday's quiz with you. These should all sound familiar. If you need to access this video again, it will be on Google Classroom in today's folder. I wanted to mention the fact that yesterday we covered 5-6, which was inequalities. That topic is actually not on this quiz. So the quiz that you're taking on Monday only covers 5-1 to 5-4, like it says on here. On the very end of this document, if you were to flip it over, I made a list of all of the notes that you should have that will be helpful to you. So these are all of the notes. If you want to try to find them, you don't really need them right now because I'm going to go through these questions with you. This is just repeating what I already said. This cloud right here is saying this is not on your quiz, but you will be doing an exit card on this today that you will be turning in just so I can see how you're doing with the topic. And then pretty soon, before we know it, you will have a test too. So keep in mind your test as of now is on December 18th. It's a Wednesday. Keep your warm-up sheets. You have warm-up sheets for this week. I'll take those from you on Monday, so just hold on to them for now. On Monday, I'll record all of the homework and everything. So this first question is something that we did at the very beginning of the unit. To see if this ordered pair is a solution, I just need to plug in the x and y values. So obviously we know this is x and this is y. So we're just going to plug them into each equation. So in the first equation, we have 7, x is 3, minus 4, y is 1. That's supposed to equal -1. So 7 times 3 is 21. Minus 4 times 1 is 4 equals -1. You get 17 equals -1. Well, 17 definitely does not equal -1, so that is not true. So as soon as you find one that's not true, your answer is no. If that one had been true, we'd have to move on to the next one. And if both of them are true, your answer is yes. Otherwise, it's no. So the next one says solve the system of equations by graphing. Again, this was toward the beginning of the unit. Unfortunately, I cannot read that number because I wrote on top of it. And it can't, oh, it's -4/3. Okay, so we are graphing both of these equations. So the one that I'm highlighting right now in yellow is already in slope-intercept form, so I can graph that really without doing any work. So just can start graphing right away. So the y-intercept is this value, which is 6. So I'm going to make it cross the y-axis at 6. The slope is -4/3. So this is the slope, which means down 4 and then right 3. And my line should be going down, so I'm going to connect those. Using a ruler if you want, I can always get those out on the quiz day on Monday. And then the second equation is in what we call standard form. It's not in slope-intercept form. So to graph it, I'm going to get it in slope-intercept form so that it looks like y equals mx plus b. I'm going to move this 4x. And I have this. And then I'm going to divide by -2. So you get y equals -4 divided by -2 is +2. So that's 2x. And then 8 divided by -2 is -4. So this is -4. So the y-intercept of this is -4. 1, 2, 3, 4. And the slope is +2, which is 2/1. So I'm going to go up 2/1, and I'm going to keep doing that because remember the place where they meet is important. So this point that I'm going to highlight in the green, that's going to be my answer. Maybe green is not the best color, but that's the answer to the system right there. So connect those points, draw the full line. It is important that you actually draw these lines. They should have arrows on them. They should be straight. So this system has a solution, and the solution is the x value is 3 and the y value is 2, where they meet each other. So the solution is 3, 2. Just going to go ahead and write that and then put a box around it. Remember, if you wanted to check that, you could plug that in for the x and y values in both equations, and it should make both of them true. Just a reminder, we talked about this on Tuesday. There's no solution when the lines are parallel. So if you happen to graph them and they have the same slope and they're parallel lines, there's no solution because they never meet each other. There's infinite solutions when the equations end up being the same when you get them in slope-intercept form, so you're just graphing one line. So there's infinite solutions when the lines are, that's called coinciding, which is just kind of a fancy word for saying it's the same line. So I'll write both words here. Okay. So next, we are moving on to reviewing substitution really quick. Obviously, you have more notes on this. Again, here's all of your notes. You should have 1 day of the graphing stuff we just went over. You should have 2 days of substitution. So substitution, this equation is actually already set up really well for substitution because you have y by itself. So if you have one variable alone, you can actually take that and plug that into the other equation. So I'm going to do that now. So I'm plugging in that y. So my first equation becomes 2x plus 5, and then y is 3x minus 3. That equals 19. So when you substitute that in, you only have x's, so you should be able to solve this for x. So I'm going to go through that process. So I have 2x plus 15x minus 9 equals 19. Combine your x's, 2x plus 15x is 17x minus 9 equals 19. I'm going to add 9. I get 17x equals 28. This is kind of a strange answer. So I'm going to divide by 17, but 28 divided by 17 is going to be some sort of decimal. Hold on, I'm going to grab a calculator. So 28 divided by 17 is like a weird decimal. It's like 1.65-ish. So we actually haven't done any that turned out quite this strange, but that's okay. So I'm going to turn it to about 1.6. I'm just going to round to the nearest tenth. So then plug that in to the second equation to find y. So plug this in right here for x. So we have y is approximately equal to, because I rounded that x value, 3 times 1.6 minus 3. So 3 times, end up getting about 1.94, etc. So I'm going to say about 1.9. Now that might round a little bit differently just because I actually did not type 1.6 in my calculator. I used the whole previous answer on the calculator because it is a little bit more accurate. So I'm getting about 1.9. Yours might be a little bit different from that, but I'm getting y is 1.9. So approximately 1.6 for x, 1.9 for y. They usually turn out a little bit nicer than that, but it doesn't hurt to see an example that's not quite as pretty. Okay, the next one is another substitution one. So remember, you want to look at both equations and find the variable that's easiest to isolate, which in this case is this y, because it doesn't have a coefficient. So I'm going to solve for that y first. So to solve for that y, I want to, oops, hold on, sorry, I have the highlighter. To solve for that y, I want to first move this x. So I'm going to minus 2x. So I get negative y equals 5 minus 2x, or negative 2x plus 5, whatever way you want to write it. Solve that for y, so divide by negative 1. You get y equals negative 5 plus 2x, because you're dividing by negative 1. I actually don't love plugging things in that have a negative first part to them. So I'm going to change the order of that. You don't have to. It doesn't matter as long as you do it properly. But I'm going to say y equals 2x minus 5. So I'm just switching the order. So take that, and you always want to plug that into the other equation. So plug it in for that y. So you have 3x plus 4, 2x minus 5 equals 2. Solve that, distribute the 4. You have 3x plus 8x minus 20 equals 2. Combine like terms over here. You have 11x. Good, this one's going to turn out a little bit better. Oops. So we have 11x minus 20 equals 2. We're going to add 20. You get 11x equals 22. Divide by 11. You get x equals 2. Okay. Now you want to plug that in to figure out what y is. So take that and plug it in for x in either original equation, or it would be smarter to plug it into this one because y is already isolated here. So you have y equals 2 times 2 minus 5. 2 times 2 is 4. 4 minus 5 is negative 1. So y equals negative 1. So our solution here doesn't need to be rounded because it's not decimals. So that's my answer there. So those are my substitution answers. If you want to see more examples, you have a lot more in your notes packets. And I even have other videos linked on Google Classroom in the individual folders. So the last thing we're going to go over is elimination. Elimination, you want them to be in standard form. So remember, standard form is ax plus by equals c. Looks like these equations are actually already in that form. Notice the one system has a bracket around it right here, and the other one doesn't. There's really no meaning to that bracket. It doesn't need to be there. In other words, you do them the same whether it's there or not. So in this first one, it looks like the x values are already opposite, which makes it easier. So you can add the equations together right away. When you do that, the x's go away. They're eliminated because they're opposite. Negative 1y plus 5y is 4y. 10 plus, or negative 10 plus negative 6, I almost missed that negative, is negative 16. Divide by 4, solve for y, you get y equals negative 4. Now we want to figure out what x is. So to figure out what x is, you have to take that y value and plug it into either equation, whatever equation looks easier to you. I'm going to use the first equation, but whatever you want to do is fine. So plug that in there. So I have 7x. It's minus y, but y is negative, so it'd be minus negative 4, so it'd be plus 4. Solve that. You get 7x equals negative 14. Divide by 7. You get x equals negative 2. So then your answer is always x, comma y. Make sure you don't write it backwards. I'm seeing that happen occasionally, so just pay attention to the fact that it should be x and then y. So that's your answer. Again, if you wanted to check that, you could plug them both into the original equation. And then we have one more elimination one here. Again, it's already in standard form, so no rearranging is necessary. You want to get either x or y opposite. Remember, it always works if you just multiply by the other coefficient. So for example, if I wanted to get the x's opposite, I could multiply the first equation. I'm actually maybe not going to do it this way, so you don't necessarily need to write this down yet. I'm just kind of explaining it. You could multiply that one by 3, so that this would be a 6, and then you'd multiply the second equation by the other coefficient of x, which would be a 2. But remember, they're both positive originally, so one of those needs to be negative. So that would work. Or you can get the y's opposite. Again, it always kind of works if you think of it as multiplying by the other coefficient. So if we focus on the y's, this is actually originally a 1. So if you just multiply this first equation by positive 5, that will be a 5 now, the coefficient on the y, which is the opposite of negative 5. So you don't need to multiply the second equation by anything. So multiply this by 5, you get 10x plus 5y, or do the x's, it doesn't matter, equals negative 5. The second equation we're not doing anything to, so I'm just rewriting it. Add the equations together. These are eliminated. You get 13x equals negative 26. Divide by 13. X equals negative 2. Plug that in wherever you want to find y. The first equation looks slightly easier to me, so I guess I would use that one. So 2, x is negative 2, plus y equals negative 1. Negative 4 plus y equals negative 1. Add 4. You get y equals 3. So your solution is negative 2 and then 3. Okay. Now just a quick reminder of Monday's lesson. So on Tuesday, we didn't have school this Monday. If you're doing substitution or elimination, sometimes special solutions exist. So when you're going through the process of either substitution or elimination, if the variables go away, and you have a false equation, then there's no solution. If the variables go away, so no variables remain, in other words, and you have a true equation, then there are infinite solutions. Remember, you can use symbols for these as well. So no solution, sometimes we write it like this, and then infinite solutions, I'm okay with you writing it like that. So you also have notes on elimination. You have 2 days of that. So 2 days of elimination. And then the special solutions is what I was just talking about in terms of the no solution and infinite. You have notes on that. And then we also did a day of word problems, which do show up on your review and on your quiz. So I think that's it for now. If you need to watch this again, you can. At this point, your sub is going to pass out 2 things to you. One of them is a quiz review that you're going to work on during class today. The other one is an exit card on 5-6. I kind of want you to do hopefully you can finish them both during class today, but do the quiz review first. The exit card you're going to turn in before you leave, and I would say save maybe the last 5 minutes of class to work on it, maybe 5 or 10, and you're just going to turn it in before you leave. Remember that section is not on the quiz though. As far as Monday's quiz goes, we will have a little bit of time to go over questions if you have any. Plan on turning in your quiz review that you're working on today. And then if you typically take the quiz elsewhere, like the study center or whatever, if you want to do that, that's totally an option to you, but I want you to come check in with me first. Okay, I think that's it. Please be good for the sub, and I will see you on Monday.